On the evening of July 17, 1996, TWA Flight 800, a Boeing 747-100 bound from New York's JFK Airport to Paris, exploded in midair over the Atlantic Ocean just 12 minutes after takeoff, killing all 230 people on board, including passengers and crew. The sudden and catastrophic disaster shocked the nation and triggered one of the most intensive aviation investigations in history. Eyewitnesses initially reported seeing a fireball in the sky, which led to speculation about a missile strike, terrorist attack, or other external causes, fueling widespread fear and media frenzy. However, after painstaking analysis, the National Transportation Safety Board, NTSB, concluded that the cause was a fuel tank explosion in the center wing tank, which ignited the flammable mixture of fuel vapors and air inside the mostly empty tank. The ignition was traced to a likely electrical short circuit, possibly involving wiring running through the tank or nearby components, which provided the spark that caused the devastating blast. Once the tank exploded, the Boeing 747 broke apart in midair, scattering wreckage over several square miles of ocean and leaving little chance for survival. The disaster prompted an unprecedented recovery operation. Investigators and Navy divers retrieved the majority of the aircraft's remains from the ocean floor, including critical components such as the center wing tank, engines, and flight data recorders, which were essential for reconstructing the events leading to the explosion. The NTSB's investigation, which lasted 4 years, not only identified the technical cause but also highlighted design vulnerabilities in fuel tank systems, aging wiring, and maintenance practices that could allow flammable conditions to develop unnoticed. In response, the Federal Aviation Administration, FAA, mandated significant safety improvements, including the implementation of inerting systems to reduce fuel vapor flammability, stricter inspection standards for electrical wiring near fuel tanks, and more rigorous maintenance protocols for aging aircraft. Airlines worldwide adopted these measures to prevent similar tragedies, fundamentally changing fuel tank safety and electrical system oversight in commercial aviation. The public reaction was a mixture of grief, outrage, and a demand for accountability, with families of the victims advocating for faster adoption of safety measures and more transparent investigations. The crash also reshaped emergency response planning, search and recovery operations, and the way aviation authorities communicate during high-profile disasters, balancing technical accuracy with public concern. Ultimately, TWA Flight 800 became a turning point in aviation safety. A single electrical failure in a vulnerable system led to a catastrophic midair explosion, but the lessons learned resulted in widespread safety reforms, improved aircraft design, and preventive measures that have saved countless lives since. The tragedy remains a somber reminder of how hidden vulnerabilities in aircraft systems can escalate rapidly and the critical importance of rigorous safety standards, maintenance oversight, and investigative diligence in preventing future disasters.